There we go.
So, welcome to the last week of class for this course. Yes?
Should we watch Klaus instead?
Can we watch what instead?
Klaus.
Clouds?
Klaus.
Klaus? Oh, no. Unfortunately, unlike the squishy subjects, we have work to do. Yeah, I'm sure everybody would feel the time were better spent in me talking about the exam and related issues. So, basically, this week has been set aside for exam review. I think that this should take two forms, personally, and I had time for both of these things in the other section, so I think everything will work out here as well. Number one, I would like to complete the example that we were working on last week with making the fake Twitter thing, as that reviews a lot of concepts which we have been, exploring through the later half of the course, right? It not only works in a lot of the REST stuff, not only conceptually, but in practice, and it also works in quite a bit of the database stuff, and also we're going to integrate sessions into it, and those happen to be, well, two of them anyway, fairly major topics on the final exam. So, it would be useful to see a practical demonstration, in my estimation. But, the other thing which was quite profitable in the other class, which I think we should do again, just kind of a general Q&A. I go through the topics that are likely to be on the exam, and you guys ask questions about those topics. And I, go over the material once again, based on user feedback, as it were. So, that would be the order of the week this week, I believe. Any objections? Wonderful. There is one other thing that I am unfortunately required to make known. So, apparently, it has become practice for some students who are in sections other than this section to attend my section because they don't like their professor in their other section, basically. I've been told by my superior in the organization that this is a practice that I need to put a stop to somehow. I'm not going to be taking attendance because I've at no point taken attendance. Oh, you've also sat down right by the camera. If you're okay being on camera on this, yeah. Basically, if you're here from another section, you should be attending the section that you are assigned. I'm not going to actually physically kick you out though, because I'm not going to call security or anything. I think that's probably an overreaction. But yeah, that's, just so you know, the opinion of the management is that people should attend the sections that they've been assigned, regardless what you think about the professor. So, yes, well, that would be not my particular purview. I agree, though. I believe that if you're going to be paid to do a job, you should be good at it. But yeah, so basically there was a complaint. In that complaint, it was mentioned that people were going to my classes instead. And to my knowledge, this was only one guy, but the way that the letter was phrased, it made it seem like there was a health and safety problem happening where I had 100 people in a room like this, which is obviously not the case. Probably what most people have been doing is watching my videos, right? So be it, I'm not going to stop doing the videos unless I receive directed instruction from my boss not to. So, anyway, that's that situation, that little piece of nastiness. So, let's talk about the exam, shall we? Final examination. There we go. So, the final exam for this class focuses primarily on the material that has been covered since the midterm. This means that we are looking at the following topics. Number 1, cookies. Number 2, sessions. Number 3, what did we do after that?
Security topics.
Hey?
Session security topics.
Ah, yes. Security. Security is kind of like, we've talked about security with just about everything else, but yes, security sessions. Next.
Database.
Yep. Databases. Also, database security. What else?
APIs.
REST API. And I am at liberty to disclose to all of you that this will not be a coding question. Or however many questions there are related to REST APIs, they won't be coding questions. They will be theoretical questions. Yes?
I remember you talked about something with hashing and salt, like salting. Will that be included in database security?
Yeah. This topic contains 2 major topics: password hashing and SQL injection.
Okay, thank you.
Make sense? So, in addition to these topics, basically everything else in the course is like stuff you probably should know anyways, you know? It's not likely that you'll be able to get away with, like, without taking inputs, for example. You know, taking inputs is very, very important element of PHP programming. So taking inputs, totally necessary. Like just kind of understanding the structure of PHP, you know, what it means to echo, you know. Another good one, single page app. It's another good one to know. So, question?
Will like object-oriented PHP be on the exam?
Haven't seen it so far. We can talk about it if you want, but within the context of this course, that bit on object-oriented was like primarily and only for the purposes of supporting using the PDO object in databases. If you remember at the time, there was like a line there that said, you actually won't be required to write any classes in this course. You can if you want to, but it's not required. That still holds true for the final exam. So Again, a good thing to know, but, you know, if you have to select what you're studying for the exams, don't select that, basically. For those of you who have a limited amount of time on this planet, perhaps that's not the topic you should be studying. So, are there any questions about this list? Okay. Is there anything that you would like me to go through? I will write them down on this board, and we will go through them one by one in the order that I think is correct, which is probably this order, actually. So, who wants to see one?
The most important thing.
Something simple?
The most important thing for the final.
The most important thing for the final? Oh, I always say the best preparation for the final is the course. So, what's worth the most points?
Yeah.
Well, if I were to select a few of these and say, these are major topics, I would put a star by databases and sessions, which probably doesn't surprise anyone, because those were the subjects of your 2 assignments in the last half of the course, right?
Question. For my assignment, I forgot to do the session destroy. I realized after I submitted it, but it's very important to do it, right? After every session, that we destroy the session.
So, it depends on the context. It's important to destroy a session when you are logging out, right? And it's particularly important if the session is containing anything sensitive or meaningful. For example, destroying the session once you are finished with your online banking, quite highly important. Destroying a session once you have won a hangman game, less.
That's what I was thinking. I was like tired and didn't update it.
Yeah. But if, are you asking for that to be a topic to be reviewed?
No, I just wanted to. Yeah, sure.
Okay. All right. Session destruction. Anybody else have something they want to see covered?
Can you just talk about like a PHP session ID and like cookies?
PHP session ID and cookies. Those are like 2 different things.
So like, isn't a PHP session ID inside a cookie?
It is a cookie, yes.
It is a cookie.
So,
Okay.
all right. Cookies, specifically PHP session ID, like just talking about it in general, or do you have something more specific? Okay.
I thought that session ID is in like the set cookie. Like I was kind of confused reading the module on sessions because it included cookies a lot. So I was wondering like how they're related, I guess.
Okay, that is definitely a question I can answer. Relationship
Like
between cookies and sessions. Excellent review topic. Anybody have anything else they'd like to see? We can go over the REST API stuff. Sure.
And the single page app as well.
REST API, single page app. Cool. Anything else? Any other ideas? Sorry, database? Anything more specific?
The database security.
Database security? Sure thing.
Specifically, password hashing again. What do you do?
Yes. Yeah. Let's do both of those. Yeah. Okay. Anything else? We can also add to the list as we go.
You can ask questions as you do.
Yeah. This is a review, so your participation in this class, or in this review session is even more important than usual. Does everybody have this?
Yep.
Okay, I'm going to erase it then. Wait.
Let me see the picture.
Alright.
Well,
There we go. So, let's talk about cookies first. Let's start with cookies. So, what is a cookie?
It's a small store of data in the browser.
Yes, it's a small piece of stored data stored in the browser or the client. Yes. So, cookies are stored in client. How do you create a cookie?
Set cookie.
The set cookie function. How do you access a cookie?
The super global.
Yep. Yes. So when the server wants to store something on the client for later retrieval, a cookie is set in that PHP script. On the next access, the client will send all cookies which have not expired, which are relevant to that domain, along with its HTTP request packet automatically. The server does not need to request cookie data from the client. It is sent by default. So, for example, if we have the client and the server, if the client initializes a request, when the server is handling that request, sorry, I'm beginning to overheat. It's kind of warm in this room, isn't it?
Maybe you can leave the door a little open.
People are always talk so loudly in the hallway because it's like a bunch of couches. People think just because there are a bunch of couches they can relax. Man,
How dare they?
I know. Friggin' people. Man. Sometimes in my brain I liken students to dirty laundry because they kind of just like lay around on the floor and in corners, just like dirty laundry does. You know? It's actually a lot worse at the university because there's like a lot less like space for them to actually be and to exist. They cram them in a lot more. But anyway. So the client initializes the request. At some point during the execution of the PHP script, setCookie gets called. This includes a cookie in the response packet. So once we send response, that response includes a cookie. The cookie is then stored on the client. Along with the processing of any other information that's been sent in the response packet. remember that the cookie is not the only thing being sent in the response packet. All of our regular response data is being sent and processed as normal, right? The cookie is a little something extra which is being sent along with the request packet. Then, the next time this client accesses this server, that is to say, it initializes a second request, so long as the cookie has not expired in the intervening time, the cookie is sent by the client automatically. This is true for however many cookies you have. So the cookie is sent, the server then receives the packet and stores the cookie value, in the superglobal. The way that you check to see if the client has sent you a cookie with a particular name is using the isSet function. isSet, and then whichever cookie name you're looking for. Right? The same way that we originally tested to see if get or post parameters were set in the incoming request packet, right? So, yeah. Question.
Oh, so when you like enter any website, is a cookie automatically made always?
When you enter a new website,
Yeah, like when you load up a new web page.
no, the cookie is only set if the server calls set cookie.
Okay.
If the server does not call set cookie, then no cookie is set.
Okay, and you said it sends a response. Is the response like a header type response, like a set?
Yeah, the cookie is sent in the header,
Okay.
I believe.
Yeah.
So it's not part of the payload.
Okay.
Yeah. The cookie is sent as part of the response header.
Okay.
But yeah, I mean the server is going to send a response.
Yeah.
Right. You know, the cookie is just sort of slapped on the
Yeah.
on the top of it.
Okay.
But here is a cookie. You know. So yes. So your server-side code can do different things depending on whether or not the cookie has been included in the response packet, right? So in terms of what cookies are used for, most of the time, if you were to take a look at sort of wild cookies on the internet, cookies in the wild, most of them contain serial numbers or some other form of cryptographically secure series of digits and letters. The reason for this is that cookies are not a secure means of data storage. It's very simple, actually, to modify a cookie. All you have to do is find the cookie inside of your inspector pane, double-click on the value field, and you can set the value of the cookie to anything you want. This means that the cookie itself is not secure. The values that come inside of this cookie being sent back by the client might have been modified by somebody with nefarious intentions. In other words, they may send you a poison cookie. Right? So, when dealing with cookies, it's always very important not to do anything excessively stupid, like echo the contents of a cookie directly to a web page. Right? Or, basically do anything with the cookie whatsoever aside from sanitize it. Right? You need to sanitize it first. It is originating in the client, and what do we never do with clients? We never trust the client. Right? Yes?
Is there anything stopping like some malicious user from
creating like an insanely large amount of cookies, sending it in an HTTP request, and then like slowing down your server's processing time?
The tons and tons of cookies attack, maybe? I don't think so, in theory. Yeah, I mean, servers would be vulnerable to this the same way they'd be vulnerable to a DDoS attack, right?
Oh, yeah.
Like, the server has no way of preventing someone from doing something like that, right? The server infrastructure needs to receive the packet before it knows what's in the packet, how many cookies were attached, and, you know, it basically, there's no way of telling before it's read it that, you know, this particular packet contained the Girl Guide's entire output for like 3 months, you know? So yeah, I guess that would be, that's kind of like, that's one of those fun little attacks that you can't really do anything about, and like you can maybe detect that it's coming in, and maybe your ISP can do something about it. But yeah, it's like kind of in the same category as a DDoS attack, but I don't think there's anything theoretically preventing it. There is a cap on the size of a single cookie. It's something like 4 kilobytes, which is pretty large actually. I don't know if there's any limit on the number of cookies that can be received. It might, like browsers might have restrictions, but a packet does not have to originate in a browser,
Yeah.
right? So, yes?
Is there like HTTP only, like flags or something?
Oh, yes. So, another element of cookie security, the process that I described would be someone going in and modifying the cookie value manually, right? One thing that's true about programmers is we hate doing anything by hand, right? You can set cookie values in JavaScript as well. So HTTP only is a flag that you can set in the set cookie function. When you set that flag, it disables access from JavaScript for that cookie, which in general, unless you yourself are relying on that for your client-side code, which you probably should rethink how you've designed things, setting that to, you know, HTTP only to true is a very, very strongly necessary security consideration, and it's also not the default setting in PHP.
Yeah.
Probably because if it were, it would break a bunch of people's websites. So, yes, good. So that's cookies, that's cookie security. So now, let's move right along and talk about how these relate to sessions. So, this is not universally true of sessions. It is possible to maintain a session without cookies, but in this class we are studying the use of cookies to create and maintain sessions. So, from our perspective in this course, for the purposes of the final exam, all sessions use cookies. Not all cookies are sessions, right?
So it's like a square rectangle kind of thing.
Yes, yeah, exactly. Not all rectangles are squares, but all squares are rectangles. All sessions are maintained by cookies, but not all cookies maintain sessions, right? So you remember how I was saying that most of the time the thing that's stored in your cookie is some kind of, like, it looks like an encryption key, right? The session ID number is one of these secure numbers. The reason that they're used, it's the same reason that a credit card number has 12, 15 digits. It makes it difficult to guess a valid number, right? And with the security code on the back, that adds like, you know, not only do you have to guess 1,000, or not only do you have to guess a valid number, which is, you know, difficult, you also have to, you then have a 1 in 1,000 chance of guessing the correct security code on the back if you were to try to brute force somebody's credit card credentials, right? So this is the same idea. This is the same idea with these ID numbers that are contained in the PHP session ID cookie, right? It's not really useful to try to crack them because it's a brute force attack on it is going to take a very long time. So basically, if somebody malicious modifies the session ID, the chances of them hitting somebody else's session are extremely low, right? So if somebody sends in a poisoned cookie, most of the time that, or you know, the overwhelming majority of that of the time, that poisoned cookie will just bounce off of the session database because there will be no session corresponding to it, and in those sorts of cases, the server will often reissue the cookie, overwriting the poison. Right? Make sense? So, all right. So here's a question. Why would you use a cookie aside from using it to create it and maintain a session? What are other uses of cookies?
Keep like user preferences stored.
Yes, you can store user preferences. Very true. Yes?
You can store the login details to your website.
Store login data to a website? I wouldn't do that in a cookie if I were you.
So, is there a way we can secure it? Like,
No. No, because the cookie is stored on the client, it's completely unsecure, it's completely visible to any malicious person who may wish to look at it. Most users, of course, will never look at the cookie, because most users don't even know what cookies are.
okay,
Right.
so when
But-
we create a session, we create a cookie, right?
Yeah.
To communicate the session ID.
Yes.
So actually we can manipulate the session ID, right?
You can, well, you can, like on the client?
Yeah.
You mean?
since we
Yeah.
are Communicating the session ID through a cookie, we can manipulate it, right?
Yes, but the point is, if someone were to change the session ID number, overwhelmingly the most likely outcome is that they will change it to a bogus number that does not exist in the session database, because it's like you'd have better odds of taking a laser pointer and hitting Jupiter, you know? Or perhaps an even smaller planet. Jupiter is actually pretty large. Like those are your odds against naturally picking somebody else's session ID and like naturally just being able to hack their account using a random number generator, right? Very, 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 very unlikely, though technically possible, right? So there's no point to trying to modify the PHP session ID, right? You're not going to get somebody else's account that way. It's, you know, you would have to try for like, you know, hundreds of millions of years, and you probably still wouldn't be able to do it, right? On average. You might get lucky and get it the first try, but if you do, you're probably the luckiest person in the entire history of us and all other alien species that have ever existed in the universe. And that's not an exaggeration. So, you can modify the cookie when it's a session ID or something like that, but you don't want to. So the way that a person's session is validated, and this is actually something that I'm going to do once we do our continue on our not Twitter example, right? This is where that is headed. Once you have established a session, you have access to the session's superglobal. one of the things you can store in that session superglobal has this user, or, is this session validated, right? You can decouple the idea of having a session with having a valid session, right? A valid session might just be a session where the valid value has been set to true, for example. Or the way that I'm going to do it in my Twitter example, I'm going to set a user ID number in the session, and if that value is unset, then there's no user logged in, but if it is set, then you have the number of the user logged in from that client. The trick is, the session database itself is stored on the Apache server. It's internal to the server, does not ever exit the server, so as long as you're not doing something incredibly stupid, like, writing unfiltered get parameters directly into your session data, right? Unless you're doing something stupid like that, that data is considered secure, right? You can rely that that data hasn't been tampered with. To tamper with that data, your hacker would need to have root access to your server, and if they have that, basically it's game over, right? So, take the computer, unplug it, drop it in a large hole in the ground, and pile rocks on it until you forget that it ever existed. That's your solution, if you lose root access. But, yeah, does that make sense? Yeah, cool. Excellent question. Anybody else with a follow-up question on this topic of sessions and cookies? There is one use of cookies which was not mentioned by anybody, and that is the third-party cookie.
Advertisement service.
Yeah, for advertising, yeah. So, it might be instructive, very briefly, to explain this. So the issue with, basically, sessions are great, sessions are lovely, easy to set up, easy to use. The problem with a session is that it only exists on one server, right? The session data itself is not, copied and distributed across every server that ever existed, right? Each server keeps its own session data. As much as, it seems like the thing that Google's been trying to do over recent years is do exactly that. Have one long session for everybody on the internet to store all of their data so that they can, train their evil artificial intelligence. For us poor mortals who are not Google, every server has its own session database. They don't communicate. So, let's imagine the following scenario. Let's imagine we have two websites, which are both website A and website B. Both are advertising website C. Let's say it's like a banner ad or something. Go to C. Go to C. So the way that internet advertising works, C will pay the owners of websites A and B for the number of times that their banner was clicked. So here's the problem, right? Are you going to trust A and B to report to you the correct number of times that somebody clicked their links? No, that's like giving your money away, right? That's silly. You should not trust clients, and you should not trust advertisers. So, the way that C verifies who had their link clicked, right? Both of these websites will issue a cookie. The cookie's name, something like advertiser ID, right? Maybe this one has an ID of 357, maybe this one is 283, right? So, when advertiser A, when a client clicks on website A, they are sent a cookie with this advertiser's ID in it, right? This gets stored on the client's system. If the client clicks the link and travels to website C, the cookie will be sent to server C. The advertiser ID number will be read as 357. Therefore, we will know that website A was the referring site. Therefore, website A gets paid, and website B does not get paid. In order to have this work, you have to have third-party cookies enabled, right? This is what's called a third-party cookie, right? Basically, in this example, once the user reaches website C, this is the first party, this is the second party, making A the third party, right? The cookie originated in a third party. So, yeah, so use a browser that blocks third-party advertising cookies, because then it means people make less money. Haha. Actually, if you have those cookies disabled, there's almost no point in the ads in the first place, except for impressions. But let me tell you, you do not get paid for impressions the way you get paid for clicks. So, yeah, does that make sense? So that is another. You can think of the difference between cookies and sessions as being similar to the difference between, for example, a while loop and a for loop in like Java, right? The for loop does something a little bit more specifically, right? And it does quite well at that specific thing, but the while loop is a bit more flexible. It can handle everything the for loop can do, plus a few extra things as well. That's kind of the same relationship between the cookie and the session cookie specifically. Make sense? Do you think we've done this topic to death then? Any further questions about sessions or cookies? Oh yeah, session destruction. Very quickly, let's talk about it. Pardon me, destroying a session. So, when you have a session active, you will have a session database that contains information on all of the currently active sessions. Let's imagine that they have very simple ID numbers and there are 6 of them, right? So let's imagine that user number 4, session ID number 4, wishes to end their session, right? The information which validates that user is contained right here inside of the session database, right? These are the data that get exposed in the session superglobal once we have called session start, right? So if you wish to end a session, which you typically do during a logout operation or similar, you have 2 options. You can either delete the data itself. This wipes out any remaining validation or anything like that. You can wipe the data out itself. This is session unset, right? Or you can strike the entire entry in the table from existence. This is session destroy. Right? So unset deletes the data. Destroy destroys the entry, which means that the cookie has to be reissued. Yes?
What's the advantage of using one over the other? Like, which one would be more secure or like best practice?
Destroy is more secure and best practice. I don't know what the purpose of holding the entry when you've deleted everything in it would be. Like the whole point of the entry is like all it saves you is having to reissue the cookie ID, but you should be doing that anyways, like reasonably frequently. There's another function which I believe is called session regenerate. Let me look this up very quickly.
So there's really no advantage to using unset.
I don't really think so. Like, you might as well just destroy the thing, yeah? PHP session, regenerate ID, there it is. So, you also have regenerate ID. Let's imagine that we are regenerating the ID of entry number 2. Right? Or it wouldn't, you wouldn't provide the argument there. That'll just confuse people. So what that does, it picks a new random number for the session ID. Then it calls setCookie for the PHP session ID, and it overwrites the existing value in that cookie to the newly regenerated value. So in the next outgoing packet, the cookie will have a different ID number, a new ID number corresponding to the changed value in the database. Does that make sense?
Can you repeat the last one? Like, if you regenerate the same number in the database?
So it will take the data, right? The idea is the data stays the same. The data stays the same, but the ID number is regenerated. That new ID number, which is regenerated, is sent out in the next packet and set as a cookie. Does that make sense? Which brings us to one further point of cookie and session security, or particularly session security. One of the problems that you end up with sessions, the client has a valid token, right? If some piece of malicious JavaScript is executing on an unsuspecting client's machine, that token can be stolen. It's just a number. It can be ripped off and sent somewhere else, right? So, if a hacker manages to steal a session ID number, that session ID number can be used to access a user's account without having to know the login credentials, right? This is, as we say in the business, a problem. So, one way that you can attempt to counteract that is by having a smaller window of time in which such an action would succeed. This is the purpose of regenerating your session ID number. Exactly. You make it a moving target. This problem I've described to you is called session fixation. If your session ID number is too static and hasn't changed enough, that problem is called session fixation. It has a fixed ID number. You want the thing to be constantly moving so that it's hard to pin down. There's there's like a quote from The Art of War about this. Give me 1 second. It's gonna take too long to find. Okay. Anyway. So. I think that we've now given a decent treatment of sessions and cookies. Good. Does anybody need the board? No? Everybody good? Good. All right. So, database security, shall we review? Wonderful. So, let's talk about password hashing very briefly. We'll go through it. So, does anybody know what is meant by the term hash? What is a hash?
Hashtag.
No.
I think
Related, but no.
it's like a one-way encryption value.
Yes, a one-way encryption value. The point of hashing, and the reason that hashing can be used for passwords, if you have a password, for example, I don't know, kitten pants 439. What? No! Oh, it's okay. This isn't my password. So, if we hash this, we obtain a seemingly random series of numbers and letters. So, let's see. 8, 4, J, Q, 9, 7, Z, Z, X, Z, 3. Whatever. Right? The process of hashing produces this randomized string. This, in and of itself, is not that impressive. What is impressive is, so long as you're using the same hashing algorithm, every time you hash this value, it will hash to the same value. Right? This is critical. So, the reason that you store a hashed password on your database is because this is not something you want stored anywhere, actually. Any database table where you have usernames and plain text passwords which have been grouped together, that is the first target of any injection attack or attempt to breach your database of any form whatsoever. That is where all the cheddar is, right? You make it a little bit more difficult by not storing these guys in plain text. You store it in you store it as a randomized string. And that randomized string has no way of hashing back. There's no hash back. Hash is a one-way operation. This is what makes it different from encryption. If there was a way back, this would be encryption. This is not encryption, this is hashing. Does that make sense? Yes?
One thing I'm confused is, like, if there's a way, if every single way you hash that password and it ends up in that way, isn't there gonna be a way to go back if somebody figures out, like, the algorithm, or?
Would you like me to show you why this is the case mathematically?
Yeah.
Sure. So basically, this is going to be like a very mathy argument, so buckle up. Let's imagine the space of all possible passwords. So it's a set that contains every possible password, right?
Yeah.
In theory, the set of hash values is smaller, right? So, passwords, multiple passwords, may hash to the same value. So, the question becomes, if you know the hashing algorithm, the reason you can't get back to this guy is because what you get back is a set. It's not a single password. And that set could be large, right? You might receive back, the set of all passwords which hash to this hash value. Cardinality unknown.
So it'd be like number that, it would become a number that doesn't matter, like, how much time somebody guesses it, it'll just not be possible type thing?
Well, see, losing the hash values is still pretty bad,
Yeah.
right? Because the set of all passwords that hash to one particular value will be much, much, much smaller than the set of all possible passwords.
Yeah.
Right? It's not known how many it would be, right? Depends on the hashing algorithm. But, let's say we go from, 300 million possible passwords to 50.
Yeah.
Right? You can test 50 passwords.
Yeah.
Right? And to some extent, if you have a password that will hash to this, right? You don't need to know what the original password was. You can enter any one of those in the set. It will hash to the same value.
Yeah.
Right? So all we have done is made a little bit more work for the hacker. We haven't actually prevented the hacker from, this information in the database can still be used to crack a user's account, right? So, this motivates the next step up, right? Salting, yeah. So, to address particularly these problems, we introduce a process known as salting the password. By the way, the other thing about this, there's a type of attack known as a rainbow table attack, where basically you throw a bunch of common passwords. You check a bunch of common passwords, and you can check the hash values in the database, and at least a few of them will be, those common passwords, and you can, by being clever, you can figure out what the hashing algorithm is by using a rainbow table attack, and then it's basically as if you had no hashing algorithm to begin with. So, now we salt. Salting a password is the process of adding more characters to the password. This further randomizes what the hash value is going to be. So a rainbow table attack is no longer as effective. Basically, this will hash to something else. Right? It will no longer hash to the original hash value because the input is different. The input now contains this extra bit. So, in order to be able to reconstruct the password from the hash, basically, you need to know what the salt is as well to be able to get back to the original password. So, this salt must be known by the attacker to get back the original password. The trick with this, so the way that this originated, right? A website or a company or would just kind of pick a secret phrase, you know? Pick a secret phrase that's known only to them in theory, right? Maybe, you know, the thing about a salt is you can't, if you're doing that, you can't really ever change the salt because you'll invalidate your password database, right? So, you know, maybe I'm a particularly cheeky computer science professor who keeps getting in trouble for this. Microsoft sucks. Maybe that's my salt. Maybe Microsoft makes me salty, right? That's my secret password that I've made, that I've built into my server. This will probably be stored, like that salt will probably be in the source code of my PHP file or some file on my server. If anybody ever saw the salt, all they have to do to break your company's security is to, you know, write it down and pass it to some nefarious character in a back alley, right? Basically, your security is bad if one screenshot blows your whole operation, right? So, sorry, you had a question?
I was gonna say, so you would like store it in a different file, like the salt?
That would help, but you're vulnerable to the same problem. If someone has a screenshot of the contents of that file, you've lost all your security added by default. So, this brings us to the modern approach to password hashing and salting, which is that this bit you're adding to the end should be random garbage. Right? So, what we do now, we generate some random garbage, salt the password with that, and then when we generate our hash value, we store not only the hash value itself, but we also store the random garbage. Right? So every time you call password hash, it salts with a new random string. You must store the whole hash in the database and then use the password verify function, which extracts the correct number of characters off of whichever side they're stored on, and then says, okay, this is the salt, this is the hash. I can now use this salt on my incoming password from the user, try to recompute the hash, and if it hashes to this, then we have a login. Does that make sense? Yeah? Sort of? in there? No? All right. Let me try this one. So, client, server, database, right? Registration. Client sends username and password to register, right? Username, we're not salting or doing anything with, so I'm just going to talk about the password, all right? So, password, or I guess it would be like form data, right? But anyway, let's say the client enters the password 123, right? 123 is called password in a packet, right? That packet is sent to the server. The server receives the packet. It says, okay, password is equal to 123. We then call password hash. What it does, right? The password is concatenated with the salt, right? Salt is random garbage, right? Then, the hash is the, or, pardon me, let me see here. Yes, yeah, we then compute the hash of this password with the salt, right? Let's call that, yeah, hash. Then, send to database, hash concatenated with salt. Right? We imagine there's a salt variable which has been generated. Does this make sense so far? Yeah. So this guy, the salt and the hash concatenated, gets stored in the database. So, you know, it's just going to be x, 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 y, 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 y. Salt, hash. So far, so good? Okay. Now, so that's registration. For login, same input basically. The same input gets sent to the server, right? We call password verify on the received password and a hash value retrieved from the database, right? So this guy is P. This guy is the hash. You have to do the database call, right? So what it does from there, it separates the hash from the salt, right? So salt will be equal to, some substring of the hash. It's not important, right? We pulled the salt out. We grabbed this back half. We then call, we say new hash is equal to the incoming password concatenated with the salt that was extracted, and then we hash that. Right? Then return new hash equals the original hash. Not that hash, old hash, the front half, right? Equals that. Does that make sense? Yeah. That is the whole process.
Can I take a picture?
Absolutely. The password verify here is absolutely necessary if you are going to check a hashed password. You must use password verify because picking the salt out of your food is just a really it's a painful operation. Don't attempt it, right? Let PHP handle it, right? Does that make sense? So, but you may be asking yourself, but Mr. Professor, sir, if the salt is being stored on the database, doesn't that mean that if somebody has access to the database, they can still reconstruct the password? And the answer is yes. Next question. Basically, yeah, losing your database is still a very serious problem. What this is primarily designed to defeat is attacks from the front door. Right? So, good. Question?
You forgot the T.
I forgot the which?
The T.
The T?
Microsoft sucks.
Oh, Microsoft, yeah. Thank you. Here we go. There we go. All right. So, good. I think we've talked about password hashing. Did you have a follow-up question?
No, I just want to clarify that will the hash value will always be same for the specific word every time?
Yes.
You mentioned it.
Yes. Otherwise, the whole thing wouldn't work.
Yeah, when verifying the password.
Mm-hmm. Yes. If I were to compute the hash of this value multiple times and get different hash values, the whole system, it wouldn't work at all. The whole thing is predicated on the idea that if you perform the same algorithm on the same input, you get the same output, right? So, yeah. Any other questions? Shall we talk about SQL injection attacks then? If anybody needs to take a picture of that, if you wouldn't mind doing so.
Steve Adams just released his modules for hacking this week. Because when I asked last week, you said it wasn't running on the exam.
Oh,
I mean, you said there
you
was.
said it wasn't going to be on the exam?
You did.
I did?
You said
Oh,
it's not in the modules,
yeah. I sneakily released them.
so they're,
Yeah. No, I suppose not. Oh well. SQL injection attacks are definitely going to be on there though, and that's also in that release material. So, yeah. So let's talk about SQL injection attacks. So, the SQL injection attack. So let's begin our discussion by asking ourselves which things have to be disabled in order for an SQL injection attack to occur in the first place. In this case, I think it's useful to actually bring up some code, so if you wouldn't mind bearing with me. Okay. So, the goal of an SQL injection attack is to get code that you wrote to execute as code on somebody else's database, right? With somebody else's level of permissions, right? In order to write code for anything, we need to have access to our special set of code characters. This is very similar to the XSS attack, right? With XSS attacks, the reason that sanitizing the strings before we print them prevents the attack is because they need to be specific ASCII values to be interpreted as programming language constructs, right? So, basically, it's a different set of characters because we're not trying to hack HTML, we're trying to hack SQL. There's a different set of characters these two languages use, although they overlap slightly. So, in order to get an attack through, the first thing that we have to do is disable our first layer of security, which is sanitizing the incoming inputs, right? These filter operations will sanitize out special characters, but special characters will include things like semicolons, right? The set of special characters for HTML overlaps with the set of special characters for SQL, so this is one way of blocking those nasty little characters from being interpreted. So we first have to disable this. Read our parameters directly from the post superglobal, for example. So that's layer of security number one. layer of security number 2 is the PDO object. The PDO object will sanitize SQL injection attacks if used properly. If it's used improperly, it will not filter these attacks. So what do I mean by using it properly? When you are formulating your query, don't ever splice strings directly into your query using string splicing in PHP. Do not do it. Do not ever do it. If you do it, slap yourself and then undo it. Don't do it. This is what I'm talking about. This is bad. This is the bad way. I'm violating one of my rules of teaching right now. You should never ever put anything incorrect on the board, because like people will just read that and think it's correct and then do it, you know? If you do put something incorrect on the board, make sure there's a great big comically large X through it so that people know it's not, you know. Anyway, so the bad way would be something like select star from credentials where username is equal to you, or whatever you call the username variable, right? This little piece of nastiness takes your input, splices it directly into your SQL query without checking any of it, right? It just does it. It's just a string operation. And if you send that to the database, anything that's contained in this thing also gets sent to the database without being checked. So, the alternative is to leave a little question mark. If you leave the question mark in here, then during the prepare method, this string gets scanned, all of the question marks are turned into arguments, and the arguments are provided in the execute function. The execute function also checks to make sure that there are no SQL special characters or any kind of nonsense going on whatsoever. But it only does this with its incoming parameters. It will not do this here. Basically what you're saying is, nothing in here should be SQL code. This should just be parameters. This should just be parameters, and this is all the code I want executed. Question?
Did you filter client username?
I filtered client username.
Oh. So if you already filtered it, why couldn't you put it in the queries?
Because there's a fair amount of damage you can do even without any special characters. So here's an example, right? Let's say u is equal to, username is equal to, gotcha. And 1 is equal to 1, or sorry, or, right? Now, maybe you are relying on these things being sanitized out, you know? There might be ways around that too. I can't think of any at the moment, but, you know, I am not the pure avatar of internet skullduggery, so I don't know all of the ways that they would use. But basically, you can see that there's very little special character going on in that, right? An equals sign maybe, you know? Spliced into this query this will regurgitate the entire contents of the database, of the table. If all you're doing to check to see if credentials are validated is seeing if you're seeing at least one row was returned with the query, that is, something matched your username and password, this also tricks a login check, right? Very few special characters. Now, I'm not an exact expert in which particular characters filter special chars or sanitized email will actually filter, whether that's a complete overlap with the ones that SQL is looking for. So 2 layers are better than 1 layer in this case, right? This guy is specifically designed, here. This guy is specifically designed for SQL. That one is designed more for client-side stuff, JavaScript and, bad emails or something. So, yes?
What about using things like bind instead of doing like an
Bind?
execute? Yeah,
Instead of leaving what, sorry?
like execute. Like on assignment 4, instead of doing like the parameter inside the execute, you can make like a bind and put it in there instead? Or should you just do that instead?
I'm inclined to say this is PHP, so there are 5 different ways of doing everything.
Okay.
This is the version that appears in the slides pertaining to the subject. So, if you
Okay.
know this is worth full marks.
Okay.
If you make me look something up on the exam, I will look it up.
Okay.
I will, and if it's correct, I will give you the marks for it.
Okay.
But
Just use it.
I want to go on vacation. Please don't make me look things up on your exam. Every time somebody makes me look at something up on their exam, the Professor Moore pissed off-o-meter raises just a little bit, and you don't want me marking your exams while I'm pissed off. So, no, I'm completely objective at all times when doing all of my grading. Thank you, especially when a robot is doing it.
What he's talking about
Yeah.
is what the professor posted in discussion.
Oh, okay. Well, let's take a look at it then.
So I bet you just get ChatGPT to create all the exams for you.
Yeah, no, I definitely get. No, I write my own robots. Thank you very much. Let's take a look. Who's the professor that posted it? Discussion group. Oh, assignment 4 using database. Okay. Is this the one? Oh. Let's see. This is correct. Yep. 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 This is true. Yep. To use real prepared statements. This is fine. This is just a different way of doing the same thing. Okay, so there are two ways to prepare these queries, right? The first way is to use question marks. Question marks use the stuff passed to execute positionally. So if I have question mark, question mark, question mark, question mark, and I pass A, B, C, D to execute, A gets put in the first one, B gets put in the second one, C in the third one, and D in the fourth one, positionally, right? The alternative to doing that, you see the colon here? That designates a parameter. It's like a named question mark, right? So the alternative to this, if I rub this out for a moment, if I have colon x, colon y, colon z, and then to execute, I pass an associative array, x gets A, z gets C, and y gets B. The result of that will be A, B, or A, B, C, like that. Does this make sense? It's a way of hooking up the spots inside of your query string to the keys of an associative array, rather than relying on position and unnamed parameters. So in theory, this makes it a little bit more clear what you're doing it this way. All execute is doing is this multiple times looping over the thing that was passed. That's all this is. It's just taking that bit where you pass it directly to execute and like popping it up above. For some reason, I'm not sure that it is, well, I guess the reason to do it is you can specify the parameters as integers, whereas over here, everything is just strings. So, integer is a more restrictive character set than a string. So in theory, it's more secure to do it that way, I suppose. But, yeah, Tom knows what he's talking about, but I'm not sure, this might be going a little bit far, I think using execute is just fine for this class. They do mostly the same things. Does that make sense? Good. Any other questions? Okay. So, shall we call SQL injection attacks finished then? Good. So, let's talk about single page app then. Single page app is reasonably simple in concept. Conceptually, there's not a huge amount going on here. The idea of a single page app is that rather than having, a large number of HTML files that you're linking between and pulling from and going between, you have but one or a small number of HTML files which have PHP scripts integrated, which modify that file in order to change the appearance of the web page based on server parameters. When we do our not Twitter example, I'll show you how to set it up so that if the user is not validated, all they see is the login page, and if they are validated, all they see is the interface, right? It's reasonably easy to do. The whole thing hinges, does anybody need this? No? Okay. The whole thing hinges on the ability to mix and match PHP tags and HTML tags. So remember that the opening PHP tag fires up the PHP interpreter. Anything outside of a PHP tag is interpreted as regular HTML, right? So you can flip and flop, turn it on, turn it off. You can read out the values of variables in PHP directly by using this. Question mark equals is a shortcut for echo. So basically, you kind of have two main modes of PHP, right? You have, like, this isn't necessarily distinguished in, like, the packets themselves. This is more distinguished in, like, where, like, what is being requested and how, you know? But semantically, basically, you've got two different types of PHP scripts. You've got PHP scripts which are basically meant for AJAX requests, which send a piece of data, right? Not a web page, a piece of data, right? And you've got the PHP scripts which generate a whole web page, right? The ones that generate whole web pages are of the single page app style. Does this make sense? We'll do an example of it next time in class. Okay? Okay, good. So I'll call that topic done then for the time being. So let's talk about the REST API. There are a couple of things that are important to know about REST APIs. Number one, it is important to know that different request types correspond to data operations of various types, right? GET requests have a specific interpretation as a database operation in SQL, for instance. What is a GET request in SQL?
Select.
Yes. What is a POST request? Insert, yes. So, get, select, insert, pardon me. Post is insert. Put is update and delete. You got away from me. Anybody want to guess? It's delete, yeah. Right? So the whole point of REST is using the internet infrastructure to convey additional information, right? We are using the request type to request different types of operations. That makes sense. We are also using return codes intelligently. Not everything will be a 200, right? If you are performing a delete operation and the user does not have permission to delete the thing they're trying to delete, what should they get? Well, yeah, the first of the operation shouldn't happen, right? But in terms of the HTTP response code, right? Not a teapot. No. Teapot's the wrong one. It's either a 401 unauthorized or a 403 forbidden. You have a little bit of like leeway to decide which type of response you want to put down, but this is like, these are less cut and dry rules. These categories overlap to a great degree, but you know, for example, 400 bad request is basically like a catch-all for everything else, you know? But yeah, not acceptable, conflict, gone, payload too large. You probably wouldn't have to do that. And of course, everybody's favorite, I'm a teapot. So, it's also important to know that we can override the direction of a URL inside of a subfolder to some specific PHP file, right? Before REST API, if we had a URL like https://mysite.ca/this, that, and the other, right? Originally, each one of these would have to be encoded in the directory structure on the server. Otherwise, you're going to hit a 404, right? Unless there is this folder containing a folder that, containing a folder and, containing a folder the, and containing a folder other, and unless that other has like an index page or something. Well, you'll get like the Apache default thing, but basically, unless those directories actually existed, you would get an error. With htaccess, you put htaccess in some folder, and instead of looking up that position, it says basically, the rest of this URL be parameters. These are now all parameters. We redirect this to something like a dispatch script, and then everything gets sent, everything addressed to subfolders gets sent to that single script instead. Meaning, this space is freed up to contain interesting and useful data necessary for operations. One of the ways that this is used is to select between different kinds of get, post, put, and delete operations. For example, in our Twitter example that we're going to be doing, selecting all posts versus selecting posts from a specific user, those are both going to be GET requests. That's not enough information to distinguish the two different operations in our API. But once you've put some parameters in here, that becomes enough information. Does that make sense? Good. Any further questions? Yes.
Will there be questions from the REST API part for the exam?
Yes, in theory, but not in code. Yeah. Okay. I brought it. All right. I would like a motion to dismiss. Can I have a seconder?
Second.
All right. All in favor of dismissing class, say aye.
Aye.
All opposed, say nay. The motion is carried. You're welcome.
Is the same for PHP, so like we have it now, like a website, feeding time, like on time.
Not using like nice little object-oriented DOM stuff. No. As far as PHP is concerned, the entire website is just a string. So you don't have nice methods like append child or create elements. They don't exist in PHP.
Like in the examples we are doing, every data is sent as either JSON code or a string.
Yes.
Yes. Have a specific function to represent the string, like to update the web page.
Yep.
Is
Then yeah.
convey.
Yeah, yeah, because you can't modify starter code, right? And all of the client-side stuff is starter code. So, yeah, no, I mean, there's no like append child in the client. Yeah, like, if you want to just like send an instruction to the client to like add a table or something, you can't. Especially from an AJAX request, right?
Like if I want to update the site on time or in the current time when the site is being used by a user or the site is being loaded by a user, is it possible to update the client?
No, once the client loads it, they have to refresh the page to get any updates. They have to get a fresh copy from the server, right? You can update the server while the client has the page loaded. The server is not in any way aware that the page is loaded by any number of clients, right? All it is the server. It's just serving requests. Anybody who requests the page gets the new updated version of the page.
So if like I put it in the standard code, I put it in function or something, repeatedly fetch the PHP script, and through that PHP script, I can update the standard code. Is it possible? Yeah, I just
Man, that's such a waste of bandwidth.
So when I saw it, see, it was like, oh, okay, I didn't realize you were.
I mean, in theory, you could write the client so that it was continuously refreshing itself. Or checking to see if checking to see if something changed. It's not trivial.
really check it, like
Maybe.
it is fetching the PHP script and updating, asking for it.
It's not exactly a scalable solution. How many simultaneous users are you intending for this website? You know, are they all going to be fetching the website every half second? You know?
So yeah,
Yeah.
only when
You'll see it in your Amazon Web Services bill, right?
So which will be the most important part for the finance?
I'm not gonna pick between sessions and databases. But I think narrowing it down to 2 for you, I've done you already a pretty big service. Yeah.
So we don't have much question from the first initial part, right? That we covered for the.
It's certainly